Snow has been falling for 6 days. Outside, the wind is strong enough to strip skin. Somewhere under 3 feet of drift, a shape rises from the frozen ground. Not a hill, though it looks like one. Smoke bleeds upward from a slot in its back, curling sideways the instant it meets the wind. Inside that shape, 40 people and 20 animals are breathing the same warm air. A woman turns meat over a fire pit that runs the length of a bus. A child sleeps on a raised wooden platform, wrapped in sheepskin, close enough to hear a cow shifting its weight a few feet away. Somewhere above their heads in the dark, smoke gathers in a thick ceiling that never quite clears. It is -30 outside. It is close to freezing at the walls. And at bench height, where the family lives, it is warm enough to work with bare hands. This is a Viking longhouse in the dead of winter, and nothing about its comfort is an accident. Every layer of it, the shape of its walls, the placement of its door, the animals living inside it, even the snow burying it alive, was doing a job. Together, they turned a wooden and earth structure into one of the most effective cold-weather buildings pre-industrial humans ever built. This is how it worked. Start with the shape, because the shape came first. The people who built these houses spent much of their lives at sea, and it shows. Longhouses were long, sometimes over 80 meters, with walls that bowed gently outward, the same curve you'd find on a ship's hull. That wasn't decoration. A straight wall meets wind head-on and takes the full force of it. A curved wall lets the wind slide around, the same way water parts around a bow. The orientation mattered just as much as the shape. Builders set the long axis of the house against the prevailing winter wind, so the narrow ends, the ones most exposed, took the brunt of the weather, while the long sides, where the doors were, stayed relatively sheltered. Inside, there was no maze of rooms. One great hall held almost everyone: the family who owned it, the people who worked for them, sometimes the animals too. That wasn't just how Norse society organized itself. It was also, whether the builders framed it this way or not, a heating strategy. More bodies in one enclosed space meant more heat, generated for free, all night, every night, all winter. The longhouse wasn't a building in the way we usually mean the word. It was closer to a hull turned upside down and packed with a crew that never disembarked. Here's a detail that surprises most people. In large parts of Norse territory, Iceland especially, there wasn't enough timber to build a proper wooden house. Trees were scarce, and what wood existed was too valuable to burn or waste on walls that had no real insulating power anyway. So builders used wood only where nothing else would do the job, as a skeleton. Thick posts of pine, oak, or birch were sunk deep into the ground and set on a base of flat stones, which kept the timber up out of the wet soil and slowed the rot that would otherwise have brought the whole frame down within a few winters. The walls themselves were something else entirely. Between the posts, builders packed turf, blocks of soil cut thick with grass roots, stacked like oversized bricks, sometimes laid in overlapping courses to kill off any gaps. At the base, these walls could reach 1.5 meters thick, occasionally close to 2 meters, tapering slightly as they rose for stability. That thickness is the whole trick. Turf isn't a good insulator because dirt is magic. It's a good insulator because it's full of trapped air, held in place by a dense mesh of roots. Trapped, still air is one of the best insulating materials there is, which is exactly the principle behind modern fiberglass batting or foam board. The Norse had found their own version of it, centuries before anyone understood the physics, and it kept working after it was built. Grass grew straight out of the exterior, greening over in spring, its roots reaching further into the turf blocks and locking them together tighter each year. Seen from a distance, A longhouse didn't look like a structure standing on the land. It looked like a piece of the land that had simply risen up. That was very close to the truth. The house wasn't placed on the landscape. It was grown into it. Now for the part that unsettles most modern viewers. For a large portion of the year, people and livestock lived under the same roof. This wasn't poverty, and it wasn't an oversight. It was a heating system. A longhouse was commonly divided down its length. Living space on one side, byre on the other, separated by a low partition that blocked drafts and mess without sealing off airflow. Cattle, sheep, goats, sometimes horses, spent the coldest months a few meters from the family hearth, and the arrangement benefited everyone involved. A single cow, just by being alive, gives off a meaningful amount of heat. Multiply that by a dozen animals standing in an enclosed space, and you have a second furnace running around the clock, fueled by nothing but hay. That warmth rose naturally toward the slightly higher living quarters, where it mixed with heat from the fire. The animals came out ahead, too. A separate barn, exposed on its own to open winter air, was a serious risk to livestock a family couldn't afford to lose. Tucked against the house instead, sharing its residual warmth, the herd had a far better chance of surviving to spring. There were obvious costs. The smell alone would stop most modern visitors at the door. But for people who'd grown up with it, that smell simply meant home. An unremarkable price for animals that stayed alive, and a house that stayed warm without burning through the winter's entire woodpile in a season. Comfort in this house was ranked well below survival, and by that ranking, the arrangement made perfect sense. If turf walls were the armor, doors were the weak point, and Norse builders treated them that way. Windows barely existed. Glass was rare and expensive, mostly reserved for churches, so ordinary houses had none. A few had narrow slits that let in a sliver of light in summer, but come winter, those were plugged solid with moss or straw. The trade was blunt: light for heat, and heat won every time. Most of daily life happened in near total darkness, broken only by firelight. Doors got far more engineering attention than windows ever did. They were built low enough that an adult had to duck to get through, which cut down sharply on the volume of cold air that could rush in with each opening. They were also thick, tightly fitted, and hung not on iron hinges, but on wooden pins, turning in carved sockets, a simpler system that could still seal remarkably well when built with care. The cleverest trick, though, was the entryway itself. Many longhouses had a small, unheated vestibule in front of the main door, a buffer room. You'd step in from outside, pull the outer door shut behind you, knock the snow off your clothes, and only then open the inner door into the heated hall. Two doors, never open at once, meant the freezing air from outside never had a direct path to the warm air inside. It's the same principle used in modern building airlocks and industrial cold storage entrances, arrived at independently, centuries earlier, out of necessity rather than theory. Even the position of the doors was chosen with the wind in mind. They were placed on the long, sheltered walls rather than the exposed gable ends, and rarely faced each other directly, which would have let a draft cut straight through the building. Every choice, however small, was aimed at the same target: keep the wind out, whatever the cost elsewhere. At the center of it all was the hearth, not a stove, not a fireplace, but a long, shallow trench of fire running down the middle of the hall, sometimes stretching 10 meters or more, lined with stones that did double duty, containing the flames and storing heat, then releasing it slowly back into the room long after the fire had died down to embers. This one fire did almost everything. It heated the hall. It was the only real light source in a house with no windows, throwing shifting orange light across carved wooden posts and smoke-blackened rafters. And it was the kitchen. Cauldrons hung above it on chains or tripods, simmering the soups and porridges that fed the household. But a fire that size, burning constantly, produces a serious amount of smoke, and longhouses had no chimneys. So where did it go? Up, and then nowhere for a while. Smoke rose and pooled beneath the roof, filling the upper part of the hall in a dense, acrid layer that thickened as the night went on. That sounds like a design flaw. It wasn't entirely. The constant exposure to hot smoke cured the timber roof beams the way meat is cured in a smokehouse, driving off moisture, killing wood-boring insects, and extending the life of a roof structure that would otherwise have rotted or been eaten through within a generation or two. Eventually, the smoke needed an exit, and that came through a single adjustable opening at the roof's peak, directly above the hearth, the only real window the house had, doubling as its main source of daylight. In winter, that opening was pulled almost fully shut, using a long pole to control a wooden cover, leaving just enough gap to vent the worst of the smoke while sacrificing as little heat as possible. The air inside stayed thick, smoky, and far from what we'd call comfortable. But comfort wasn't the goal. Staying alive until spring was. And a hall full of smoke that stayed warm beat a clear one that didn't, every time. The roof carried the same logic as the walls, layered for a different job. At the base was a wooden frame, rafters and thinner cross laths forming the structural skeleton, strong enough to bear what was about to be piled on top of it. Over that went sheets of birch bark, laid like shingles, overlapping so water would always run down and off rather than finding a way in. Birch bark holds natural resins that make it close to waterproof on its own, and Norse builders leaned on that property heavily. Then came the turf, the same insulating logic as the walls, applied overhead. 2 or 3 layers of turf blocks, sometimes weighing several tons in total, were laid across the birch bark. That weight is exactly why the wooden frame beneath had to be so robust. A turf roof pressing down on a poorly built skeleton would eventually cave it in. The payoff was worth the engineering. That mass of earth trapped heat the same way the walls did, stopping it from simply rising straight out through the roof and being lost. It also protected the delicate birch bark waterproofing underneath from sun damage and physical wear. And, like the walls, it came alive. Grass took root across the roof within a season or two, its network of roots binding the turf blocks into something closer to a single solid mat than a stack of separate bricks. From outside, a longhouse in summer could look almost entirely covered in lawn. That wasn't neglect. It was the roof doing exactly what it was built to do: hold heat in, keep water out, and get stronger with every passing year rather than weaker. Most cold climate builders treat snow as an enemy to be cleared. The Norse largely let it pile up because they understood something about it that's easy to miss. Snow is mostly trapped air held in a lattice of ice crystals. That trapped air is a genuinely excellent insulator, which is the exact principle behind an igloo, and it's why a longhouse's sloped roof and gently curved walls, without sharp corners to shed drifts, were left to gather snow rather than fight it off. As storms passed, drift built up against the walls and across the roof, sometimes deep enough to bury the house almost entirely, leaving only the smoke vent and the vestibule entrance visible above the surface. From a distance, a whole settlement could look like nothing more than a cluster of snow-covered hills. Rather than digging the house free, people mostly left the snow where it landed. A meter or more of packed snow acted as an outer thermal shell wrapped around walls that were already thick with turf, smoothing out the wild swings of an Arctic winter. Even as the temperature outside fell to 30 below and a storm tore across the open ground, the surface beneath that snow blanket could sit close to freezing, stable, buffered, and far less brutal than the open air just a few feet away. Put together, the house had 3 layers of defense working in sequence: the timber frame holding everything up, the turf walls and roof trapping heat inside, and finally, a shell of snow smoothing out whatever the weather still had to throw at it. Nothing in that system was working alone. Each layer only did its full job because the layer around it was doing its own. Inside, the layout reflected the same instinct for efficiency running through the entire structure. Raised wooden platforms ran along both long walls, benches by day, beds by night. They existed at that height for a specific reason: cold air sinks, and the ground-level earthen floor stayed noticeably colder than the air even a half-meter above it. By raising the living area onto these platforms, people effectively lifted themselves out of the coldest layer of air in the room. The space between the platforms, floor level, running the length of the fire pit, was the working area: cooking, tending the hearth, moving between tasks. Life in the house operated on 2 levels at once: the working floor below and the living platforms to either side, in a layout that echoed the deck arrangement of the ships these same communities built and sailed. At night, families slept on those platforms under wool and animal skins, often still dressed for warmth. In the dim, smoke-hazed light of the hearth, most of the day's activity, eating, working, talking, sleeping, happened within a few meters of that one central fire, because that fire was, in every sense, the only reason any of it was survivable. None of this worked because of any single idea. It worked because every part of the house was doing more than one job at once, and all of those jobs pointed in the same direction. The curved walls deflected wind before it ever reached the door. The door itself, low and double-sealed, stopped what little wind got through. The turf, in both walls and roof, trapped heat the same way trapped air always does. The animals added a second, living furnace running on nothing but hay. The hearth lit the hall, cooked the food, and cured the very beams holding the roof up. And the snow, instead of being fought, was left to wrap the entire structure in one more layer of insulation, for free. Strip away any one of those elements, and the system gets noticeably worse. Keep them all together, and you get a building that could hold a stable, livable temperature through months of Arctic dark using nothing but timber, turf, fire, and the body heat of its own occupants and livestock. It wasn't luxury. It wasn't comfortable by any modern standard. Smoky, dim, and pungent with animals for half the year. But it worked, winter after winter, for centuries, without a single calculation written down anywhere. Sometimes the best engineering isn't the kind that shows off. It's the kind that just quietly keeps people alive until the sun comes back.